Welcome back to the deep dive. Today, we're focusing all our attention on one figure who has, well, fundamentally reshaped the infrastructure of modern computing.
Jensen Huang.
The CEO of Nvidia. I mean, his company's valuation just soared past that staggering $4 trillion mark.
It makes him arguably the most influential executive of 2024.
Without a doubt.
And, if you want to understand how we got here, and this is the important part, where we're going, you really have to look at his playbook.
And the sources we have today are pretty incredible. We've got his fireside chat at SIGGRAPH 2024, deep analyses of his management style. It's a unique blueprint.
Yeah, it really is.
So we're jumping straight in. What's our core mission for this deep dive?
Okay, our mission is to unpack the most, I'd say, radical elements of Huang's vision.
Radical in what way?
Well, we need to understand his predictions on how jobs will be totally transformed. Then there's his claim that AI accuracy problems, hallucinations.
A big one.
That they're essentially already solved. And then the most counterintuitive idea that generative AI will dramatically reduce global energy consumption.
Right, and then tie it all together with how his highly unconventional management structure actually fuels all of this.
It's all connected.
It seems to be all connected by his central philosophy, isn't it? This idea that you have to will the future into existence.
Absolutely. This is a CEO who succeeded by defying the logic of the entire industry. I mean, think about it. The world-favored easy general-purpose CPUs.
He declared the death of Moore's law.
And bet everything on the much, much harder path of accelerated computing. That conviction, it's rooted in decades of resistance. That's the foundation.
Okay, so let's unpack that, this foundation of conviction. Because NVIDIA's journey, it was anything but smooth.
Right. He often says, things have never trended in our direction.
And for a long time, the industry was riding high on those easy gains from CPUs.
It was predictable. Every year, you shrink the transistors, performance goes up, but it hit a wall. As Huang pointed out, the laws of physics apply.
You can shrink a transistor.
But you can't shrink an atom. And the CPU architecture, it just ran its course for scalable performance on complex tasks.
So that's why the pivot was so necessary, the shift to accelerated computing with GPUs.
It was necessary, but it wasn't easy. Far from it. General-purpose computing is simple to code for.
But accelerated computing is what he calls super hard work.
Super hard. It requires these deep, specialized software layers, like their CUDF libraries, to make the GPUs perform these really intense calculations efficiently. But that hard work became essential when the easy path just vanished.
And this is where the personal story really connects to that corporate conviction. You see this resilience in his early life.
Oh, definitely.
We know he moved to the U.S. in 1973, but the family mistake of sending him to the Oneida Baptist Institute, a reform school in Kentucky, that's just fascinating.
It's a remarkable detail, isn't it? He lands in a place with exceptionally tough students, and his daily job is cleaning the boys' bathroom.
And then working as a waiter at Denny's.
Which, famously, is where Nvidia was founded on his 30th birthday. These were really formative experiences.
It's an almost unbelievable story. Cleaning toilets, working a service job, to leading a $4 trillion company.
Yeah.
How does he connect that start to the company's ethos?
He insists the core value built there was the tolerance to take risks and the ability to learn from failure.
Built on intellectual honesty.
Exactly. It means having the courage to admit publicly when a technology or a product or even a whole strategy just didn't work.
Because if you can't admit you screwed up, you can't course correct.
Precisely. It keeps you moving. It's the precondition for innovation velocity.
That intellectual honesty is going to be essential as we transition to the biggest question of all, AI's impact on the future of work. Huang has said it's very likely AI will change everyone's job, including his own.
And he frames this not as replacement, but as augmentation. Co-pilots, the whole transformation is driven by these deeply personalized AI assistants.
For every single company, every single job within the company.
That's the prediction.
And they're already using them internally. Our sources show AI helps their software engineers debug, helps programmers code.
Even their chip designers. He explicitly mentioned that creating architectures like Hopper and Blackwell just wouldn't have been possible without generative AI assistance.
So it's not just a customer-facing chatbot.
No, it's an internal efficiency engine that accelerates the very process of creation.
Which brings us to the elephant in the room, accuracy. The infamous AI hallucinations.
Right.
If we're going to rely on these assistants for our jobs, they have to be reliable. And Huang's claim is that the tech to fix this is It's already here.
That is a massive claim, and he details 3 specific technologies that, when you combine them, are designed to fix that accuracy crisis for enterprise use.
Okay, so walk us through them. What are the 3 breakthroughs he's betting on?
The first is the one that made models like ChatGPT usable in the first place. Reinforcement learning human feedback, RLHF.
Using humans to fine-tune the model.
Exactly. You're using human judgment to align the AI on desired skills, on core values, on factual accuracy. It's essentially teaching the AI how to behave.
Okay, so that's the alignment piece. What's the next guardrail?
Well, that's literally what it's called, guardrailing. This is tech packaged in frameworks like their NEMO system that forces the AI to stay in a very specific domain.
So it stops it from, what did he say, wandering off and pontificating?
Exactly. It prevents it from talking about things it doesn't really know, limiting the knowledge it can draw from.
But doesn't that still introduce risks? I mean, if it's relying on general training data, it could still synthesize old or just plain wrong information.
It does, which is why the third breakthrough is arguably the most powerful solution for corporate reliability. Retrieval augmented generation.
Harsh. Harsh. This fundamentally changes how the model gets its information.
Completely. Instead of just using its internal memory, the AI first fetches answers from a trusted, up-to-date database. Think all the company's internal documents or every article you've ever written.
Ah, so it acts like a verification layer. It grounds its response in verifiable, indexed truth.
It's not just synthesizing. It's retrieving and then synthesizing. It becomes an authoritative chatbot of you, trained specifically on your content.
It bypasses the big, messy, hallucination-prone general data.
And forces the AI to be authoritative on a specific, vetted set of information.
That makes perfect sense for an enterprise setting. Okay, let's pivot to maybe the most controversial topic, energy. The power demand of AI is just staggering. But Huang argues accelerated computing is the solution, not the problem.
He's incredibly insistent on this. He claims GPUs are just dramatically more efficient than CPUs for the same work.
The numbers are huge.
He's citing efficiency gains of 20, sometimes even 50 times. So his imperative is that we have to accelerate every application we can just to save energy.
Okay, that's compelling for a single data center. But here's the claim that really stopped me in my tracks.
I think I know which one.
Generative AI will actually reduce the internet's overall energy consumption. How on earth does that math work out?
It forces you to rethink the fundamental physics of the internet. He argues traditional computing is retrieval-based.
Meaning?
Every time you watch a video or load a story, you are retrieving static data from a remote data center. And that retrieval, the network traffic, the storage activation, consumes huge amounts of power.
So the constant fetching is the real energy drain.
Precisely. Generative AI, on the other hand, can generate it right there on the spot because we understand the context. Or it can use content already on your device.
So you're cutting out the retrieval costs.
If enough of what we currently retrieve can instead be generated contextually, he believes it results in a net energy reduction across the whole ecosystem.
That is a huge conceptual shift, and it changes where you build the infrastructure.
Absolutely. If energy is the new bottleneck, he predicts that future data centers will be located in areas with excess energy, far away from where society is today.
So the cloud will be determined by power availability, not proximity to users.
Exactly. He has this great adage for it. AI doesn't care where it goes to school.
The training location doesn't matter for the eventual use case.
Right. You can train a model in a remote location with abundant, cheap energy, and the model is still available globally.
So if accelerated computing is today's engine and the energy paradox is solved, what's next? What's the next multi-billion-dollar market for them?
All sources point directly to robotics and the Omniverse.
Digital twins.
Exactly. The digital twin market is expected to exceed $100 billion by 2030, driven by manufacturing and smart cities.
Define the Omniverse for us simply, beyond the sort of metaverse buzzword.
Think of it as a virtual platform, a high-fidelity lab, where developers can build realistic digital simulations of the physical world.
And the big benefit is how it accelerates learning, specifically for robots.
It completely eliminates the slow, expensive, and risky process of real-life trial and error. Robots can train in thousands of simulated scenarios at once inside the Omniverse.
Learning to navigate obstacles or handle things like a box falling off a shelf.
All of it. It just drastically accelerates deployment time and cuts costs.
And we have a great concrete example of this with BMW.
Yeah, they're using Omniverse Enterprise to create virtual replicas of their entire global factory network. That's over 30 plants.
coordinating the manufacturing of 2.5 million customized cars a year.
And here's where simulation meets reality. They use tools like Isaac Sim inside Omniverse to train their delivery robots with synthetic data.
So the robots practice virtually before they ever hit the real factory floor.
Countless scenarios. It proves that the true power of the GPU isn't just generating images, it's generating safe, useful data.
That incredible velocity demands a unique organizational structure. And arguably, the most unique thing about Nvidia isn't the chip, but the man running it and his completely unorthodox management style.
It is a radical rejection of corporate norms.
Designed to keep the organization as small as possible.
Right. Let's look at the 6 key strategies. First, the most shocking one. He personally manages about 60 top leaders.
60 direct reports. That's absolutely insane. Most management theory says 7 to 10 is the max.
He argues they're senior people. They don't need career coaching from him. His goal is strategic alignment, not hand-holding. This extreme span of control just minimizes management layers so information stays fluid.
And he doesn't do scheduled one-on-ones, which is the second strategy.
Right, which connects to the third, his famous refusal to give private feedback.
No secret meetings, no closed-door performance reviews.
None. All feedback is given publicly. And his rationale is simple. Feedback is learning. Why are you the only person who should learn this?
It turns every individual correction into a collective lesson.
Which requires that radical transparency you see in strategy number 4. Transparent reasoning.
He models his thinking process.
Exactly. He doesn't just give an order. He walks the team through how he reasoned through a decision. That empowers them to make smarter choices on their own later.
And that transparency also covers strategy 5, embracing public mistakes. The nobody fails alone ethos.
Absolutely. Failure has to be brought into the spotlight to accelerate collective learning. You dissect it as a group lesson. You don't punish it as an individual shortcoming.
And finally, number 6, the founder mode urgency. How do you keep a $4 trillion company feeling hungry?
He historically starts meetings with the provocative line, "Our company is 30 days from going out of business." That intensity, even if it's a joke now, it keeps the focus incredibly high.
And the planning process defies every business school textbook. No 5-year plan, no 1-year plan.
No plan. They use continuous planning instead. They're constantly observing and adapting in real time, ready to change course immediately.
But how does he, with 60 reports, know what's actually happening on the ground? He avoids status reports.
He calls them meta information because they're distilled and biased. Instead, employees send him short, daily emails, their top 5 things.
A sentence or two.
Just a few lines. He uses these to stochastically sample the system, to get a raw, unfiltered sense of the ground truth.
And they deliberately mix up meeting attendance.
Yes. They'll put new college grads in high-level strategic meetings with veterans. It forces information to travel fast, challenges old assumptions, and stops silos from forming.
That was a truly deep dive into the blueprint for the AI era. We covered the shift to accelerated computing, the 3 technical fixes, RLHF, guardrailing, and RG, that he claims can solve AI accuracy.
The surprising energy idea, that generative AI might actually reduce internet consumption, and of course, the potential of digital twins in the Omniverse.
And it's all driven by this man who maintains the urgency of a startup while leading one of the most valuable companies in the world.
He's the longest-serving CEO in Silicon Valley, and he jokes about becoming a robot in 30 years just to work another 30. His success is that coupling of relentless innovation with a management philosophy built on radical transparency.
And that transparency is the key takeaway for you listening. I mean, if the value of knowledge is in its application and AI is set to change everyone's job, how will you use intellectual honesty and a tolerance for public risk-taking to accelerate learning in your own career? The foundation of future success might just be found in fostering a culture where you can admit failure openly and learn from it collectively, instead of trying to bury it.
Well said.
Okay, that was a truly deep dive into Jensen Huang's blueprint for the AI era. We'll catch you on the next deep dive.